Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 3 video on the chapter of symmetry where I will solve the first test paper 1 on the chapter of symmetry. This test paper 1 will have 12 MCQs, that is multiple choice questions, and ideally you should be able to solve this test paper 1 in 45 minutes. So this video is part of the playlist CBSE Maths for class 7 following the textbook of author R.S. Aggarwal. If you are new to my channel or not yet subscribed, or if you are visiting my channel for the first time or seeing this video for the first time, and if my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel. So let's start solving the test paper 1. Okay, so I have the test paper 1 on the left hand side. I hope it is visible properly. And on the right hand side, I will solve the paper. So this paper, as you can see, has 12 questions. All the questions are MCQ. Each question has 4 choices, A, B, C, D, and one of the choice is correct, which you have to mark. Now, it is always recommended that before you try to solve the problems of this test paper 1 in yourself first, even if you cannot solve all the problems in 45 minutes, give it a second attempt or even third attempt, and then if you are stuck at any problems and if you cannot solve it, then you can see this solution video as a reference. And while I will be solving the problem, I will pause for a few seconds after solving a problem so that you can take a screenshot of the solution for your future reference. Okay, so let's start solving the problems. Now, since a symmetry is based on figures, the figures of all the questions, I have tried my best to draw them as properly as I can, but it may not be perfect. But I hope you will understand the essence of the question, and the figures should not be bothering you to understand the problem. Okay, the first problem. It is given that in this figure two circles of okay, let me quickly check if everything is visible or not. Okay, in this figure two circles of different diameter are touching at a point A. Okay, if x is the number of lines of symmetry, and y the order of rotational symmetry of this figure, then the value of x into y is. Okay, so it is saying that x is the number of lines of symmetry and y is the order of rotational symmetry of this figure. Then the value of x into y is. So, in a sense, so definitely we have to find the value of x. That is, we have to find the number of lines of symmetry and the order of rotational symmetry. Okay, so it is given that the figure is. Let me roughly draw the figure. The figure is something like this. This is a circle, and let's say somewhere at point A, okay, let me draw the other. We have another circle touching. They are having a contact. They are touching at the point A. Okay, so this is the point A. Okay, and the diameters are different. Now diameters are different. Now definitely the diameters are different. Okay, now let's understand the lines of symmetry. Now we can see that the lines of symmetry. Okay, they are touching at a single point, and since so if I draw a straight line touching the joining their centers. So let's say this is C1. Let's say, now I should have drawn the figure a little bigger. Anyway, let's say C1 is the center of the smaller circle, and let's say C2 is the center of the bigger circle. Now, if I draw a line passing through the center C1 and C2, so this is the line Let's say this line is L. Now this line, now if you can imagine, if you can visualize properly, this line that is joining the two centers will also be passing through the point A. So this line definitely will divide the entire figure into two equal halves, and those two equal halves will be identical, because above the line, this line, above the line we have two semicircles. That is one semicircle of the smaller circle and another semicircle of the bigger circle. Similarly, we will have the same semicircle of the bigger circle below the line and the same semicircle of the circle smaller circle below the line. So definitely we can say that let me so the line L joining the two centers has to be a line of symmetry. Has to be a line symmetry. Now, why this line L be a line of symmetry? Because we can say that the figure, this line is dividing the entire figure, that is the two circles, in halves. So the above half, that is the semicircle above the line of the bigger circle, this figure, that is the semicircle of the bigger circle, is definitely identical to the semicircle of the same bigger circle below the line. These two are identical. Similarly, for the smaller figure, the semicircle below the line, this semicircle is identical, will be identical with the semicircle above the line. Hence, we can clearly say that the figure above the line and the figure below the line are identical, and hence L has to be the line of symmetry. Which is, what is this line L? L is the line joining the centers of the two circles, which also will pass through their point of contact A. Now, is there any other line? Is there any other line that can be a line of symmetry for this entire figure? No, because if you think of any other line, like any vertical line, if you think of any vertical line, you consider any vertical line, it will not divide the entire figure into identical halves. Or so this is the only now this is the L will be this line, this symmetrical line of symmetry L will be horizontal only if the two circles are touching in such a way such that they are the line joining their centers is a horizontal line. Now, if you draw any other line, any line at an angle or any vertical line, this line, this line, if you think, will definitely, the vertical line passing through the point A, this line is definitely not a line of symmetry. And if you consider any other line, it will not be a line of symmetry. So clearly, X is the number of lines of symmetry is equals to 1. Now, what about the order of symmetry? Order of rotational symmetry. Order of rotational symmetry. Now, so what is order of rotational symmetry? If you rotate this entire figure about a point such that it will at more than one angle, at more than one different angles, the entire figure will look identical, then it will have a rotational symmetry. That is, if you rotate this figure at certain angles, if you rotate this figure up to 360 degree, if you rotate this figure by some angles, and if at certain different angles of rotation until a whole rotation, that is 360 degree, if at those angles of rotation the entire figure looks identical, then it will have a rotational symmetry if the number of those angles is greater than 1. Now, always remember that any figure will always have at least order of rotational symmetry 1, because any figure if you rotate, if from its initial position, if you consider that angle to be 0, if you rotate the figure about 360 degree, it will come back to its original position. So it will be identical. So n equals to 1 is the minimum order of rotational symmetry for any figure. Now for this figure, if you consider certain standard angles, that 90 degree, at 90 degree, this figure will be something like this. Now I am drawing a very approximate figure. At 90 degree rotation clockwise, this figure will be like this. So this is if you rotate 90 degree. So definitely this is not identical to its original position, considering this figure at 0 degree is its initial or starting position. Now after 90 degree clockwise rotation, this figure is not looking identical. Now if you rotate from this position, if this position is 1, if you rotate from position 1 180 degree clockwise, it will look something like this. It will look something like this, and this is of course, so these it will look like this. So this is after 180 degree rotation clockwise. So this is also not identical to the position 1. Now if you rotate the original figure, let's say 270 degree clockwise, it will look something like this. This is also not looking identical to the given figure. So this was 270 degree, and if you rotate this figure, the original figure 360 degree, not 360 degree. Wait a second. 90, 360, 180. So after so this was figure 2 after 90 degree clockwise rotation, and this was figure 3 after 180 degree clockwise rotation, and this was figure 4 after 270 degree clockwise rotation, and of course if you rotate 360 degree, the original figure, it will come back to its original it will look like the original. So this is position 5 after 360 degree. So only rotating this figure 360 degree clockwise, you are getting its identical, it is looking identical to its initial position. So for this, the n which I considered, which I always denote n as the order of rotational symmetry of any figure. If you have followed my notes, theoretical videos, part 1 and part 2, you will know that I denote n as the order of rotational symmetry of any figure. So for this figure, n is basically 1. So which is that y is equal to 1. So order of rotational symmetry of this figure is 1, and this figure is definitely not having a rotational symmetry. So hence x into y is equal to 1 into 1 is equal to 1. 1 is the answer. So the correct choice is B. The correct choice is B. Okay. So let's do problem number 2. Problem number 2 is saying that for an English alphabet letter L, let okay, some symbol is given. The first symbol is sigma. This is the symbol of sigma. It is known as sigma, and it is having a subscript of L. So sigma L is saying for an English alphabet L, let sigma L is the number of lines of symmetry of L. Okay, so this is equal to number of lines of symmetry of L. And L is what? And L is a letter. It could be any English alphabet. It could be any letter from the English alphabet, that is A to Z. From A to Z, L represents any letter from A to Z, and it is saying that sigma L is the number of is the number of sigma L is the number of lines of symmetry of L. Okay, and this is alpha. This is alpha. This symbol is known as alpha. So alpha subscript L is the order of rotational symmetry of L. Okay, and there is another symbol theta, which is this symbol is known as theta. Theta subscript L is given a formula. This is equal to sigma L multiplied by alpha L. Okay. Okay. So for any letter, a letter L represents any letter, English letter. So sigma L is representing the line of the number of lines of symmetry of that letter. Alpha L is representing this alpha L is representing the order of symmetry of that letter, and this theta L is a formula. It is just the sigma L multiplied by alpha L. Okay. Now what it is saying? Then arrange the letters of the word maths. Arrange the letters of the word maths in ascending order of their theta values. In ascending order of the theta values. So in the word maths, what letters are we having? We are having M, letter M, A, T, H, and S. These letters we are having in the word M. So we have to arrange these letters M, A, T, H, S based on their theta values. That is arrange them. That is basically we have to arrange these letters based on so we have to find theta M based on theta A, we have to find theta T, we have to find theta H, and we have to find theta S. So based on these, all the theta values of all these 5 letters, we have to arrange these letters in ascending order, and what will be that order? That order in ascending order based on the theta values is given as choice, and we have to choose the correct choice. Okay, so definitely we have to find the theta values for all these letters. So for that we have to find the sigma L and sigma and alpha values of these letters. So what is sigma M? What is sigma M? That is, what is sigma M? Sigma M is the lines of the symmetry, number of lines of symmetry of the letter M. So what is the lines or number of lines of symmetry of the letter M? So we have M. If we have M, we know that the lines of symmetry of M is 1, because this is the vertical line. This line is only the line of symmetry of the letter M. There is no other line of symmetry for the letter M. Okay, so sigma M is 1. What about alpha M? That is the order of rotational symmetry of the letter M. Okay, so if I rotate the letter M clockwise 90 degree, I get this. This is not looking identical to the original M. Okay, so this is 90 degree rotation of the letter M clockwise, and what will be how will the letter M look after 180 degree clockwise rotation? It will look like W. So this is 180 degree after 180 degree clockwise rotation of the letter M. See, still it is not looking identical. What about if we rotate the letter M 270 degree clockwise? It will look like this. This is after 270 degree clockwise rotation of the letter M. Still it is not looking identical to M. And if I rotate 360 degree, obviously any figure after rotating 360 degree, it will come back to its original it will always look like original, as the minimum number of order of minimum value of order of rotational symmetry of any figure is 1. Okay, so what is alpha? Alpha is the order of rotational symmetry of L. So definitely for M, the order of rotational symmetry is 1. Is 1. This implies theta m is equal to this implies theta m is equal to 1 into 1 equals to 1. Okay, so we have theta m equals to 1. So like this, we have to find all the theta values for all the letters M, A, T, H, S. So let's see what is. Let's do A. What is sigma A? That is the lines, number of lines of symmetry of A. So we know that this is the letter A. Definitely, the only line of symmetry is the vertical line. That is basically, if you name the some endpoints of the letter A, B, C, D, E. So this line, the line of symmetry of the letter A is basically bisecting, is passing through the, is basically the bisector of the angle A, and it also bisects the BC, segment BC. So that is the what this vertical line is the line of symmetry, and there is no other line of symmetry for the letter A. So sigma A is 1. Okay, what about alpha A? That is the rotational order of rotational symmetry of A. Let's see, if I rotate A 90-degree clockwise, I get this. So this is 90-degree clockwise rotation of the letter A, which is not looking identical to A. Okay. What about when we rotate this letter A 180-degree clockwise, we get an upside down A. So this is also not looking identical to A. What about if you rotate the letter A 270-degree clockwise, we get this. This is also not looking identical to letter A. So definitely the next angle will be 360-degree, and obviously it will look identical to letter A. So definitely the order of rotational symmetry for the letter A is 1. So this implies theta A is also equal to 1 into 1 equals to 1. Okay, fine. What about T? Sigma T, the lines of symmetry, the number of lines of symmetry of the letter T. So T is like this. Now T is like this. Okay. Now how many lines of symmetry does the letter T have? Obviously the vertical line, this will be a line of symmetry. Is there any other line of symmetry? No, there is no other line of symmetry. So definitely sigma T will be 1 for the letter T. What about alpha T? What will be the order of rotational symmetry of the letter T? Let's see. If you rotate the letter T clockwise 90-degree, we get this. So this is clockwise 90-degree, which is not looking identical to T. Okay. If we rotate the letter T 180-degree clockwise, we get this. This is also not looking identical to T. Similarly, we will get this after 270-degree of rotation clockwise. So definitely we can also see that the letter T is also having order of rotational symmetry as 1, because only when it is rotated 360-degree, it is coming back to its original position, orientation, and it will look identical. And no other angles between 0 and 360-degree, if you rotate by that angle, the letter T, it will look identical. So order of rotational symmetry of T is also 1. So this implies theta T is equal to 1 into 1 equals to 1. So we have theta T equals to 1. We have theta A equals to 1. We have theta M equals to 1. So for MAT, theta is coming as 111. Okay, let's see H. What is sigma H? That is the number of lines of symmetry of the letter H. So H is this, and we know that for H there are obviously two lines of symmetry. This is the first line of symmetry, and this is the second line of symmetry. So sigma H is 2. For the letter H has two lines of symmetry, the vertical line and the horizontal line as shown. Now what is the order of rotational symmetry of alpha H? The order of rotational symmetry of H. Now let's see, if you rotate the letter H clockwise 90 degree, we get this, which is not looking identical. Okay, if you rotate the letter H 180 degree, 180 degree clockwise, you will get this, which is looking identical to the letter H. So at 180 degree, it is looking identical. And what about if we rotate the letter H clockwise 270 degree? It will look like this, which is also not looking identical as the letter H. And then again, if you rotate the angle to 360 degree, by 360 degree from its original letter H position, it will look identical. So at the angles of 180 degree and 360 degree, the letter H is looking identical to its original position at 0 degree. So the alpha H, that is the order of rotational symmetry of letter H, is 2. So this implies theta H is equal to 2 into 2 equals to 4. So theta H is equal to 4. Okay. Theta H is equal to 4. Okay, fine. What letters are left? S. We have to consider S. Sigma S, that is the lines of symmetry of the letter S. The letter S, always remember, has no lines of symmetry. You cannot draw any line that will divide the letter S into two identical halves. So sigma S is always 0. Now if sigma S is 0, we need not compute the value of this, because anyway we will always get theta S as 0 because theta S is sigma S multiplied by alpha S. So 0 multiplied by some question mark, whatever that value is, this will be always 0. So theta S is 0 just because sigma S, that is the number of lines of symmetry of S, is 0. Okay. So now we have computed all the theta values. So the least value is S. The theta, we have to arrange the letters of the word maths in ascending order of their theta values, that is from smaller to bigger values. So obviously S will come first, and then we have the theta values of the theta values of MAT are 111 and H is 4. So MAT, it should come MAT, and then finally H. H has the largest theta value, which is 4. So this should be, now MAT has equal number of theta values, that is 111. So instead of MAT, you can rearrange MAT in any order, but S should be the first letter and H should be the last letter in the final ascending order. And so definitely the correct choice is C. C is the correct choice. So this question was little complex and little conceptual. I mean, if your fundamental concepts about the rotational symmetry, order of rotational symmetry, and the number of lines of symmetry for all the letters are clear, you should be able to solve it very easily. Okay, so you can I don't know, you can I'm pausing the video, scrolling and pausing the video so that you can take screenshot of the solution. Okay, let's do problem number 3. Problem number 3. Which of the following figures have no line of symmetry? Which of the following figures have no line of symmetry? Rectangle have no lines of symmetry. No, rectangle we obviously have. For any rectangle, obviously we have two lines of symmetry. That is the line joining the midpoints of the opposite sides. So uh, these are the two midpoints of opposite sides. If we join them, this is the line of symmetry. Again, these two are the midpoints of opposite sides. If we join them, this is another line of symmetry. So definitely A is not a choice because A has two lines of symmetry. Rectangle. What is a kite? A kite. Okay? So how? What is the shape of a kite? A kite looks something like this. You have this kind of figure, a kind of rhombus, but in rhombus all the four sides are equal. In kite, only two corresponding sides are equal. So these two sides are equal, and these two sides are equal, and you know that the diagonals are these two lines. These two lines, and a kite has only one line of symmetry. As one line of symmetry, that is basically this line. This line L, no, sorry, I'm sorry, not L. This line L is the line of symmetry, which is the bigger diagonal, which is the longer diagonal. Always remember that in a kite, the two diagonals are not of equal length. I don't think in a kite, I'm not sure. In a kite, can the two diagonals be of equal length? No. And also remember that okay. So in what is the basic what is the basic how do you what are the geometrical geometrical properties that defines a kite? So it is a quadrilateral, four sides, and you have two sides. So A, if what happened if the kite is A, B, C, D, we have BC equal to CD, and we have AB equal to AD. Also, we have AB is not equal to BC. Now, if AB is not equal to BC, one has to be larger. AB between AB and BC, one has to be larger. So that will make one diagonals longer. So the longer diagonals is actually the line of symmetry for a kite. Okay, so this kite has one line of symmetry. So definitely this will also be not a choice because the question is asking how which of the following figures have no line of symmetry. Okay, what is C? Semicircle. Now semicircle is like this. Semicircle is like this, and obviously the semicircle, let's say if this is AB, the center is O, and there is some the center is O, and if you draw a vertical line, a line perpendicular to AB passing through the center O, you have if you this line is actually the line of symmetry for a semicircle. This line, let's say this line, let's say this is P. This line is perpendicular to the diameter. AB is the diameter, and O is the center of the semicircle. So any a line perpendicular to the diameter AB passing through the center O is the line of symmetry for a semicircle. So it has one line of symmetry. All semicircle has one line of symmetry. So this is also not a choice. So obviously the correct choice has to be parallelogram, because you must know that any parallelogram look like this, that is opposite sides are parallel and also equal. So if this is a parallelogram, there is no line you can draw if you think the diagonals will not be a line of symmetry. The diagonals will not be a line of symmetry for parallelograms. Even though the diagonals are dividing the entire parallelogram into two triangles which are congruent, but they don't look identical. There is a difference between, let's say, this is a very important concept that which I wrongly said in one of my video. I also made a clarification video about that. Let's say this is a line of symmetry. No, not line of symmetry. Let's say this is a line. Now consider, even though this is a line, even though it is looking a curved line, but it is a line. Let's say it is a straight line. Consider the triangle A. Consider the triangle A, B, C. Okay, consider this triangle A, B, C. I have another triangle ABC. Now the triangle ADC and ACB, triangle ADC is congruent to triangle ABC. This does not imply, when I cross imply sign, it means does not imply that AC is a line of symmetry. Because why? Because this line AC, if we consider the triangle ADC and ABC, which are the two figures that this line AC, the diagonal AC, is dividing the entire parallelogram into two figures, that is the left triangle ADC and the right triangle ABC. Even though these two triangles are congruent, they are not identical. Why? Because if you fold the right triangle, let's say the triangle ABC on the right hand side, if you fold it across, if you fold the triangle about the diagonal AC, it will not exactly coincide with the triangle ADC on the left hand side. That is the reason they are not identical. Any figure, if this is a line of symmetry, let's say for some random figure, I don't know, some random figure. So let's say this line of symmetry is dividing the whatever figure I have drawn, I don't know what is that, is dividing that into two halves. Left half is A, into two figures. The left side figure is A and the right hand side figure is B. Then this line L, straight line, will be a line of symmetry of the entire figure only if you fold the figure B about the line and it will coincide with A, or if you fold the figure A about the line L and it will coincide exactly with the figure B, only then A and B will be said to look identical and the straight line L be a line of symmetry. This is a very important concept that you must understand when a straight line is said to be a line of symmetry for a figure. So definitely D is not the parallelogram, it has no line of symmetry. So this is the correct choice. So the answer is choice D. Okay. Let's do problem number 4. Problem number 4. Which of the following letters have both line of symmetry and rotational symmetry? Now, when it is saying that a figure will have a rotational symmetry only when its order of rotational symmetry is greater than 1. Every figure, irrespective of whether it has rotational symmetry or not, it will have minimum order of rotational symmetry as 1. But order of rotational symmetry of 1 does not mean that figure has a rotational symmetry. The order has to be at greater than or equals to 2. It has to be at least 2. Has to be at least 2 or more than 2. Only then that figure is said to be having a rotational symmetry. Okay. So let's see what are the letters Z, I, N, and G. Okay, Z. Z. Now Z has no which of the following letters have both the line of symmetry and rotational symmetry? Okay, line of symmetry. Z, definitely Z will not be a choice because Z has no line of symmetry. The number of lines of symmetry of Z is 0. There does not exist any line that can divide the letter Z into two identical halves. Okay. Choice B is I. Choice B is I. For I, we know that I, this letter I has two lines of symmetry. This vertical line bisecting the vertical line of the I, and also that vertical line of the I itself. These are the two lines of symmetry of the letter I. So letter I has two lines of symmetry. Okay. Does it have rotational symmetry? It is asking which of the following letters have both line of symmetry and rotational symmetry. Now we have to check whether the letter I has whether its order of rotational symmetry is greater than or equal to 2 or not. Okay. So I when rotated a 90-degree clockwise, it becomes like this. When the letter I is rotated 90-degree clockwise direction, it looks like this, which is not looking identical to I. Okay. Now, if the letter I is rotated 180-degree clockwise, it will look like this, which is looking identical to the letter I. Now, at this point, at 180-degree angle, we can see that, which is less than 360-degree. At 180-degree angle, we can see that the letter I is looking identical. So obviously, the n will has to be greater than or equals to 2, because for any figure, n is minimum 1, which is at the angle of 360-degree. If you rotate any figure clockwise or anti-clockwise 360-degree, it will anyway look identical to its original figure. In the original figure means the figure in the original state position. So, and for any angle which is greater than 0 and less than 360-degree, at that angle of rotation, if you see any figure to be looking identical in its initial position, then that figure will have n, that is the order of rotational symmetry greater than 1, and obviously it is having a rotational symmetry. So this is the choice, as letter I is having both a line of symmetry, both letter I has two lines of symmetry, and its order of rotational symmetry is 2, one at 180-degree and another one at 360-degree. So we need not, so anyway, since only one choice is correct, n will also not be a choice, and G will also not be a choice. Letter N has no lines of symmetry. Definitely letter N has no lines of symmetry, but it could have rotational symmetry. I'm not sure, I have to check that, but letter N has no lines of symmetry. Letter G has no lines of symmetry as well. So the correct choice is B, that is the letter I. Okay, let's do problem number 5. Okay, so one figure is given. Okay, so there is a straight line AB, and there are some squares on the right hand. The squares seem to look of equal size on the right hand side and on the left hand side of the straight line A. Okay, what is the least number of squares that must be added so that the line AB becomes a line of symmetry? That is, the figure made up of the squares on the right hand side and the left hand side must look identical. Only then the straight line AB will be a line of symmetry. Now, I'm not sure whether I will be able to replicate the figure. Let me try. So this is the straight line AB. Okay, and there is one square, this one. There is one square, this one, and 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 another square, this one. Okay. Now let me approximately shade the squares so that we get a clear picture. So this is roughly or approximately the given figure, and we have to add these shaded squares. So what is the least number of squares that must be added? By that it means the least number of these shaded squares as given in the figure we must add to look identical. Now, okay, so fine. Now, definitely we have to, now since on the right hand side of the straight line A, we see this square and this square. So it has to be on the left hand side. So there has to be one square like this, and there has to be also now this square. Now my figure is not coming pretty properly, but I hope you will understand. If we have to shade the squares. So how many squares did we add so far? Two. We have to keep track. 2. Okay. Now no, sorry, I draw the figure incorrectly. This square will not be there. This square will not be there. The square will be actually this one and this one, and this one, this square. Okay. So now, okay. So for these two squares on the right hand side, we have added its corresponding squares on the left hand side so that that part looks identical on both sides. So we have added so far two squares. Okay. Now these squares, this square, the square beside on the right hand side of the tick mark, this square also has to appear on the right hand side. So I have to make the square like this on the right hand side. So I've added one more square. Now what else? Now this square, that is the square to the left hand side, it must have an identical square on the left side of the straight line AB. So this square must also be filled up. So I added one more square. Now what else? Okay. Now I can see this square. So this square, that is the square to the right hand side of the tick mark, which I just did, also need to have its corresponding square on the right hand side. So there has to be a square like this. So I added one more square. Now the figure is not more or less looking the same, but I just need to add the square to the right hand side of the tick mark I just made. We have to draw its square, corresponding square on the right hand side of the straight line AB. So for that we have to draw the final square, I guess, which will be this square. We have added one more square, and now I hope this figure is looking identical on both the sides. That is the right hand side, the figure on the right hand side of the straight line AB, and the left hand side is looking identical. So how many squares did we added? 3, 4, 5, 6. 6 squares we added. So the answer should be choice C. Okay. Let's do problem number 6. So okay, so what is this figure? A circle is there, the center is marked as O. Some sticks are coming out of the center O, and the end of the sticks are having a small circle. Okay, so in this figure, angle AOB Now let me quickly draw the figure. I'm not sure whether I will be able to draw it properly or not. Okay, and what else is there? So okay, so we have the center, and one stick is coming like this. It has a circle. One stick is coming like this. It has a circle, and it seems that the sticks are of equal length. Okay. Now, for these kind of problems on symmetry where figures are given, you have to really not everything will be very clear, but you have to somehow understand what is going on, what is actually what is the shape of the given figure, and how, which parts are symmetrical and which are not. Which this you have to have. You have to. This thing is not really mathematics, but your observation, how you see things, how you can understand the visual aspect of the given figure. Okay, and there is another stick like this, and there is another stick like this. What else is given? Angle AOB. Okay, so these are A, B, C, D, and E. Okay, and the center is O. Okay, angle AOB is equal to BOC. Angle AOB is equal to BOC is equal to COD. COD is equal to DOE. DOE is equal to EOA. Okay, so all the angles, it is saying that all the angles between the sticks are equal. They are equal to 72 degree. They are equal to 72 degree. So basically, you can say that this angle is 72 degree. Also, this angle is 72 degree. Also, this angle, all these angles, the between the two sticks is 72 degree. Okay. Now, so the sticks. Now, what is the question? What is the order of rotational symmetry? Now, the sticks are emerging out of the center of the circle. Now, circle has infinite number of symmetry. You must know a circle has infinite number of its order of rotational symmetry is infinite. That is unlimited. That is, if you for a circle, if you rotate the circle at a very small angle, it will remain the same. So just imagine if you rotate how many times you can rotate a circle until a full rotation is complete, until a 360 degree is complete. There are infinite number of angles. So that is the reason a circle has order of rotational symmetry as infinite. Now, if you rotate this entire figure about the center O, you must appreciate that since the sticks emerging out of the center O are at equal angle from each other, uh, and the angle is 72 degree. The angle is 72 degree. The fact that angle AOB is equal to angle BOC is equal to COD is equal to DOE is equal to EOA. This implies that uh, at every multiple of 72 degree, the figure will look identical. You need to appreciate this thing. Since the sticks, the circle will not matter. If you rotate the circle at any angle, it will look identical. The difference will be made by the sticks, and the sticks are emerging out of the circle. And there are how many sticks? There are 5 sticks. And the angle between each stick is 72 degree. Now, why? How? Try to understand how. Why is the angle 72 degree? It is because there are 5 sticks. 5 sticks is equally dividing the full angle of rotation, that is 360-degree. It is dividing the 5 sticks, is dividing. So basically you must have learned in your previous class in lines and angles that uh, all the angles, the sum of angles about a point is equal to 360-degree. So these sticks are making the 5 sticks are making actually uh, mm, 1, 2, 3, 4, 5. The 5 sticks are actually making 5 angles about the point O, that is the center of the circle. So 5 sticks is equally dividing the full angle of rotation, that is 360-degree. This implies each angle, this implies not each angle, this angle between 2 sticks is equal to 360-degree divided by 5, since there are 5 sticks. 360-degree divided by 5, which is 72 degrees. That is the reason the sticks are at equal distance, at equal angles from each other. Between 2 sticks, the angle is same, that is 72 degree, and this is coming from the fact that the entire 360-degree is divided by equally by the 5 sticks. So 360-degree divided by 5 is 72 degree. So if you see this kind of scenario is going on, you should always remember that the order of rotational symmetry will be 5. The order of rotational symmetry will be 5, because you can clearly understand that if you rotate the entire figure about by 72 degree, you will have an identical figure. You will have the same figure. So if you rotate from the 0 degree from its initial position, if the initial position, which is the figure given, if you consider that to be at a 0 degree angle, if you rotate it by 72 degree clockwise, then the end A will reach the end B, to B, and B will go to C, C will go to D, and D will go to E, E will go to A. So that will also look identical. If you rotate the angle, if you rotate the whole figure by 72 into 2 degrees, it will again be look identical. So for this kind of figure, the order of rotational symmetry is 5, because 360 degree divided by 72 is 5, and 72 degree is the angle between all the sticks. Okay, so the answer is 5. The order of rotational symmetry is 5. Okay, let's do problem number 7. Okay. Which of the following figures have only 2 lines of symmetry? Which of the following figures have only 2 lines of symmetry? Let's consider one by one. Option A is line. Now a line has, now this is it, the first option is line. It is not a segment. It is not a segment. A segment. Let's say AB. A segment, for a segment A, it has only one line of symmetry, which is its perpendicular bisector. You consider the midpoint of the segment AB, which is C, and you draw a line perpendicular to the segment AB passing through the point C. So this is the line of symmetry for the segment AB, but the given choice is line. A line means it is endless on both the sides. So it will have infinite, you cannot say it will have infinite number of lines of symmetry, but you don't know. Any line will, you cannot say a line, no line will ever divide a straight line into 2 equal halves. A line of symmetry at the end of the day, a line of symmetry for a figure will divide that figure into two equal halves that looks identical. So basically for A, the number of lines of symmetry is 0. A straight line has no lines of symmetry. So definitely this is not a choice because we have to find the figure which has two lines of symmetry. Okay, B, square. Now square, you must know it has how many lines of symmetry? Obviously the line joining the midpoints of the two opposite sides, these two will be obviously a line of symmetry, but also know that the two diagonals are also lines of symmetry for a square. So a square has 1, 2, 3, 4 lines of symmetry. 4 lines of symmetry. So this is also not a choice. C, rectangle. A rectangle. The rectangle has 2 lines of symmetry because a rectangle, even though a rectangle has 2 lines of symmetry, which are the lines joining the midpoints of the opposite sides. So these two are the only lines of symmetry for a rectangle. So rectangle has 2 lines of symmetry, and this is the correct choice. Now, what is triangle? A triangle has, just saying a triangle, you cannot say how many lines of symmetry it has. Now, okay, so no triangle will have 2 lines of symmetry. We know that an equilateral triangle will have 3 lines of symmetry, where the lines of symmetry are 120 degree apart by angle, and the isosceles, an isosceles triangle has 1 line of symmetry, which is and that line of symmetry is the angle bisector of the angle included by the two equal sides. So D, triangle, is also not a choice. So definitely the correct choice is C. That is a rectangle has 2 lines of symmetry. Okay. Let's do problem number 8. It is saying during a whole rotation of 360 degree, a figure is found to look identical at angles of 0 degree, 60 degree, 120 degree, 180 degree, 240 degree, 300 degree, and 360 degree. Then the order of rotational symmetry is, okay. Now always remember that a figure, whatever that figure is, let's say this is a figure. The given figure is considered to be at 0 degree angle. Start position. A given figure is always considered to be at 0 degree angle, and that 0 degree angle is never considered to be a angle of rotational symmetry. What is an angle of rotational symmetry? You start rotating the figure from 0 degree angle. You rotate through an angle, let's say theta, whatever that you rotate the figure by some angle, either clockwise or anti-clockwise, by some angle, let's say theta, x, or whatever, and it looks identical to the figure at 0 degree angle, then we say that that angle theta or x or whatever you give it name is an angle of rotation. Now that angle of rotation will never be 0 degree. It can go maximum to 360 degree. So an angle of rotation will always be less than equal to 360 degree, and greater than 0 degree. Angle of rotational symmetry. Angle of rotational symmetry. What is a rotational symmetry? An angle an angle by which if you rotate a figure by that angle, it looks identical to the figure at 0 degree angle. What do I mean by a figure at 0 degree angle? The given figure, the initial given figure is considered to be at 0 degree angle. Now from that position, from that 0 degree angle, if you rotate the figure either clockwise or anti-clockwise by some angle x, let's say x, by some angle x, that angle x, if at that angle x the figure looks identical to the figure at 0 degree angle, then x is said to be an angle of rotational symmetry, and x will always be greater than 0 degree and less than equals to 360 degree. Now, coming back to the question, it is saying that a figure is looking identical at 0 degree, 60 degree, 0 degree, 60 degree. These are the angles of basically these are the angles at which the figure is looking identical. So 120 degree, 180 degree, 240 degree, 300 degree and 360 degree. Now, among these angles, which angles we can consider as angular rotational symmetry? Those angles are 60, 120, 180, 240, 300 and 360. It will never be 0 degree. So how many angles of rotation we have? One. How many angles of rotational we have? We have 6 angles of rotational symmetry. So the number of angles of rotational symmetry is its order of rotational symmetry. So the answer is 6. 6 angles of rotational symmetry. So the choice, the order of rotational symmetry will be 6. So the correct choice is A. Okay, let's do problem number 9. A triangle having one line of symmetry and no rotational symmetry is, okay. So you know that the standard angle, the standard triangles, scalene triangle has no lines of symmetry, has no rotational symmetry. Now an equilateral triangle has 3 lines of symmetry. We know that an equilateral triangle, something like this, equilateral triangle has the basically the angles of the lines of symmetry of an equilateral triangle are the angle bisectors. That is, this is so let's say if this is the triangle ABC, equilateral triangle, ABC is an equilateral triangle, this line L is the angle bisector of the angle B, this line P is the angle bisector of angle A, and this line let's say R is the angle bisector of angle C. So these lines basically will intersect at the same point, but my figure is my figure is not perfect, so they are not looking to intersect at the same point. But anyway, this is the their point. This is a common point where they intersect. So these are the angles between two lines of symmetry is 120 degree. That is, this angle is equal to this angle and this angle. This is equal to 120 degree, and so an equilateral triangle has 3 lines of symmetry, and an order of rotational symmetry is 3. Now, what is the question? A triangle having 1 line of symmetry and no rotational symmetry. Now, that is only an isosceles triangle. You must know that an isosceles triangle, let's say ABC is an isosceles triangle where AB is equal to AC, that is the angle B is equal to angle C. The line of symmetry for this isosceles triangle ABC, where AB equals to AC, is the angle bisector of the bisector of the angle A, this line, which will also, if it intersects the side BC at D, then AD is also perpendicular. AD is also the perpendicular bisector of the side BC. So an isosceles triangle has only one line of symmetry, which is the which is the bisector of the angle included between the two equal sides, and isosceles triangle has no rotational symmetry. So the choice is C. The choice is C, isosceles. Let's do problem number 10. Which of the following letters have a line of symmetry? S. Choice A is S, choice B is N, choice C is both A and B, choice D is none of A and B. Now S, which of the following letters have a line of symmetry? S has no line of symmetry. You must know about the lines of symmetry and the order of rotational symmetry of all the English letters. S has no if you consider the horizontal line, this is not a line of symmetry, because because the part of the S above this line and the part of the S below this line, they are congruent, but they are not looking identical, because if you fold any part, either the top part about this line L, it will not exactly coincide or overlap with the lower part, and vice versa. So this is the reason this horizontal line is not a line of symmetry. Also, if you think of the vertical line, this line is also not a line of symmetry. So letter S has no lines of symmetry. So what is the question? Which of the following letters have a line of symmetry? So definitely S has no lines of symmetry. Okay. N. Now N also has no line of symmetry. If you consider this line, this the horizontal line, horizontal line. You can see that the upper part of the N and the lower part of the N are not looking identical. Also, if you consider this line, this will also not be a line of symmetry, as it is not also the part of the N to the left hand side and the right hand side of this line, this vertical line L, are not looking identical. So the letter N also has no line of symmetry. You must know this very clearly. Which letters have no line of symmetry, which letters have zero, or have no rotational order, have no rotational symmetry. This you must know and understand very, very clearly. So S and N both have no lines of symmetry. Hence, the correct answer is choice D, that is none of A and B. Okay, let's do problem number 11. How many, oh, can you see the problem? Okay, how many letters among Z, N, S, B have rotational symmetry? Okay, how many? Okay, the choices are 1, 2, 3, 4. How many of these letters have rotational symmetry? So we have to find out. Z. Let's see whether Z has rotational symmetry or not. If you rotate the Z above, the letter Z above, if you rotate this letter Z 90-degree clockwise, what will you get? What will you get? I think you will get something like this. No, you will get an N. You will get something like N. That is the letter Z when rotated clockwise 90-degree, you are getting a kind of N. So this is not. So this is the letter Z, which is looking like N after clockwise rotation of 90-degree, which is definitely not looking like Z. Okay. What will Z look like after doing a 180-degree clockwise rotation? It will look like this. It will look like this. If you consider this as the 0-degree, this Z, the letter Z itself at the position 0-degree, then you can see at the position 90-degree. By position 90-degree, I mean you have rotated the letter Z clockwise 90-degree. So at position 90-degree, it is looking like N, which is not Z. At position 180-degree, it is looking like exactly Z. Now again, the question is how many letters among these have rotational symmetry. So we just need to find to know whether a letter has a rotational symmetry or not. We have to identify, if we can identify one angle which is greater than 0-degree and less than 360-degree, at which the letter is looking identical, then only we can say it will have a rotational symmetry. Because anyway, at 360-degree angle, it will anyway look identical. And we must find another angle which is greater than 0-degree and less than 360-degree, at which angle the letter is looking identical. Okay, so we have already found that angle 180-degree, the letter Z looks identical. So definitely Z has rotational symmetry. Z has a rotational symmetry. N. Now N, since okay, so let's see N will Now, as you can see, at 90-degree position, the letter Z was looking like N. So definitely, I guess the letter N will also have rotational symmetry. Let's see. Now, this letter N, we consider it as 0-degree angle. If I rotate the letter N 90-degree clockwise, it will look, how will it look? This, if I put this, it will look like Z. If I am not wrong, the letter N, after rotating it 90-degree clockwise, it will look like Z. So, which is not looking like N. Okay. Now, again, if I rotate the letter Z, as you can see, not letter Z. So, if I rotate the letter N 180-degree clockwise, it will definitely look like Z, look like the letter N itself. So, we can see that the letter N also at 180-degree angle or at 180-degree position, it is looking identical. So, NV is having a rotational symmetry, because if we can find one angle that is by angle, I means if we, for a letter, if we rotate one angle x such that if we rotate the letter x from its initial position by that angle x, it looks identical, and x is less than 360-degree, we can always say that that letter has a rotational symmetry. Now S, let's see about S. S. So this is letter S. Let's say this is the angle, the letter S at 0-degree angle. What will S look like if I rotate the letter S 90-degree clockwise? How will it look like? It will look like something like this. This is the letter S after 90-degree clockwise rotation. Let me see if I did it correctly or not. Yes. Now, what the letter will look like after 180-degree rotation? If I rotate the letter S 180-degree clockwise direction, how it will look like S? Definitely, it will look like S. So, this, the letter S when rotated 180-degree clockwise, it will look identical. So, if this is so, we can obviously say the letter S has the rotational symmetry, because at angle 180-degree, which is less than 60-degree, it is having a rotational symmetry. That is, 180-degree is an angle of rotational symmetry for letter S. Okay. What about letter B? B. B. Oh, this is not a correct B. Okay. So this is letter B at 0-degree angle, and if I rotate this letter B clockwise 90-degree, what will it look like? It will look like this. So this is the letter B after 90-degree rotation clockwise. It is not looking identical. Okay. If you rotate the letter B 180-degree clockwise, it will look like this. This is letter B after 180-degree rotation clockwise. Now, okay. Now, if I rotate the letter B clockwise by 270-degree, it will look like this. This is letter B after at 270-degree angle position. That is, after the original letter B is rotated clockwise 270-degree, which is not looking like B. Now, the next angle will be 360-degree, and it will obviously look like the letter B. So, this letter B is not having a rotational symmetry, because only at angle 360-degree of rotation it is looking identical. There is no other angle between 0 and 360-degree at which the letter B will look identical. So, there are among the letters Zn, Sb, only 3 letters. Zn, Zn and S have rotational symmetry. So, the correct choice is C. Correct choice is C. Okay. Let's see let's do question number 12. The order of rotational symmetry of circle is, you must obviously know, it is infinite. The number of lines of symmetry for a circle is infinite, and the order of rotational symmetry of circle is infinite. This must be crystal clear to you. Okay, so this brings an end in solving the first sample test paper 1 on the chapter of symmetry. I hope this video was beneficial to you, and this set of problems will give you a good judgment of your understanding of concepts on the chapter of rotational symmetry, which involves two kinds of symmetry: reflection symmetry and rotational symmetry. So the chapter is actually reflection and rotational symmetry, or in general symmetry. If this video was beneficial, then please like it, share it with your friends, and also once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. The next video will be in solving the sample test paper number 2, which I will prepare and solve tomorrow. So please stay tuned for that video. And once that sample test paper number 2 is complete, I will also then I will possibly start the next chapter, which I am not sure what it is. What it is, I will check that later on. So after the sample test paper number 2, I will start the next chapter. So thanks for watching, and until the next video, take care and bye.